Although I think it's interesting, I heard an analogy, like in gaming or video graphics, no card has ever really achieved like, the fidelity of
Right.
like a real life, right? Or a real picture. I think that's kind of interesting if you kind of think about, because at some point, like computing for a while felt like the processors, everything was kind of fast enough, right? Or wasn't. And so it's like, it's kind of interesting when you think about AI going forward. Is it, which problem are you trying to solve? Is it just sort of like, we have to just keep going faster, faster? Is it going to take like 10 years? Or is it going to be cyclical? Like we're going to finally get to some area where the supply chain catches up
Right.
and the chips are fast enough and people can use their LLMs the way they want. So I think it's going to be really interesting over the next few years to see like which direction it goes.
Yeah, I think it's driven by use cases. And so an example, so my background is speech recognition, and many, many years ago, it was okay to release a new language or large language model, which in those days was megabytes, not gigabytes, every 6 months. This was an acceptable event. So nowadays, most of them can deliver that in a few days, and people are still complaining, right? Because
Yeah.
they're looking for the real time. So I think the use case is kind of driving these efforts, and then the hardware industry is trying to keep up and deliver that power, but they have their own limitations.
I think the industry is moving, and you touched on it in the discussions. It's moving from a training, centric model to an inference. Let's get this puppy running. Let's actually do some stuff with it. And that's where efficiency and software effectiveness and GPU, effectiveness is becoming more and more of something that has to be optimized, something that has to be done about making it better, because without it, it's just not going to happen. The adoption rate for this stuff is going through the roof.
Right. Yeah, and if you saw last week, I read an article where NVIDIA is suggesting to put a mini data center just outside of your house, and that they're willing to pay.
I've got one in the basement.
I mean, there is but yes, I think agentic AI and MCP.
I mean, agentic is nice, but it's just being able to use the stuff and actually do stuff with it. Whether you call it agentic or MCP or foundation model, it doesn't matter. I just want to do the darn thing to do stuff, and it's doing it for me now more than ever.
Right, but the difference is that agentic is like millions and billions of people doing that, while in the past it was a lot less. But I agree with you. I mean, it's almost like a quantity problem, right? Where everybody wants those high-end GPUs, and where does it stop? And I think that's where the efficiency and GPU optimization is really key. And to a certain degree, the problem starts with the large language models, right? Why do you need the large language model if you use only like a fraction of it, right? So having smaller, small language
foundation models,
it will help, right? Because then you don't need to load the whole thing in memory.
Well, the quantization, the key value optimizations that are going on, the context management stuff that's going on, all that stuff is trying to cram more AI work in less and less hardware.
But it's important that it's software doing the work, right? The quantization and all that stuff is all software.
Although I'm like really interested